Okay, start recording. Okay, so previously we have chapter 4. Okay, we talk about basic rule, basic differentiation. You need to know the rule, you need to know the proof. Then that you do the exercises so that you can actually get used to the rules. Okay, with together with the exercises here. Okay. Then now we're actually going into the next section, parametric differentiation and implicit differentiation. Okay, so let's see. Okay, so we have chapter 4. Okay, differentiation. Okay, so first C, we have parametric differentiation. Parametric differentiation. Okay, so what exactly is the parametric differentiation here? Okay, you'll be given parametric equation. Okay, parametric equation. Okay, so from a way that we draw a graph, okay, x and y. So usually we have the graph in the form of y equals to fx. Okay, if it's in the form of y and x, we call it as a Cartesian equation. Okay, we call it as a Cartesian equation. But at the same time, this the same graph that we have, okay, the same graph that we actually can write it in the other form. The same shape, the same axis, okay? We actually can write a coordinate here together with the some other parameter t. Okay, that means x in something t, y in something t. Okay, so if it's given in the form of pair like this is called parametric. Okay, equations. Okay, so let me give you some example of parametric equations. Okay. Okay, let's wait for a while. Okay. Okay. We have the parametric equation can be written in this way. Okay. So the question for here is the non-trivial form. Okay, non-trivial form. This is the trivial form. Okay. So over here we can like let's say for example for question A. Okay, you have x equals to something t, you have a y equals to something t. Okay, so the reason that we want to write it in the form of t and t, the reason that we want to create a parametric equation, if you remember from P1 where we learn about functions, we learn about 4 types of relationship. We learn about non-function and function. Parametric equation is a method for us to deal with non-function. Okay, a parametric equation is a method for us to deal with non-function. Therefore, from here, okay, we can actually split them into different form. Okay, any form that we like. Okay, of course, most of the time it's given by the question. In analogy, we actually can think about it this way. The father, mother, they have argument. They don't want to talk to each other. So the father and mother is X and Y. So they communicate to their kid Y, their kid T. Okay, so if X want to tell something to the Y, so X inform T, then T inform Y, or the other way around. So this is a parametric equation where T is, we call it a parameter. So over here, this is a parametric equation. Then from if we rearrange them, we have y equals to t, so x plus 2 squared. So this one become a Cartesian equation. So this is a Cartesian. Okay, this is a parametric. Parametric. Okay, then I give you one example for the trigo form. Okay, let's say for 3b. Okay, so we have x equals to sine t minus 3. You have y equals to cos t. So over here, we need to use trigonometry. Okay, students of course need to remember the rules that actually relate to trigonometry. So we can actually borrow from trigo sine square t plus cos square t equals to 1. Okay, so square t equals to 1. Then we can actually rearrange the things inside. X plus 3 square plus y square equals to 1. If you observe this, it's something that you're actually familiar. If you look at it carefully, this is exactly the circle equation. Okay, a circle equation is a many-to-many relationship. So this, as you can see, this is the reason why they write it in the form of parametric equation. Okay, so this is a Cartesian. This is a parametric. Okay, so you can actually try to write out the answer, the Cartesian equation from the given parametric equation for the non-trigo form and the trigo form. Let's me put down the answer. Okay, so as you can see, the sections here is talk about parametric differentiation. So parametric equation is the basic of it. So how do we actually do differentiation here? So parametric differentiation, means we want to write dy dx in terms of t. Okay, we want to write dy dx in terms of t. So how do we actually get that? So we use dy dx by using chain rule. We write it as dy over dt times dt over dx. What we're actually applying here is actually using chain rule. So from the question 4a that we have earlier, x equals to t minus 2, y equals to t squared. X equals to t minus 2, y equals to t squared. What we can do is, we do dx over dt equals to 1, dy over dt equals to 2t. Therefore, combine these two together, we have dy dx equals to dy dt times dt over dx. We have a 2t over 1 is equals to 2t. This is what we're looking for. Okay, this is your parametric differentiation. So let me give you some questions. Okay, for the parametric differentiation. Okay, So from here, you can actually see that we have some exercises here. So find the dy dx of each of the following. Okay, find equation of tangent. Okay, uh, for the parametric equation. So it will be something in the form of t. Okay, so you actually can you do the exercises here. The answer is given. Okay, on this side. Okay. Then this is section C, okay, parametric differentiation. Then from next one, we look at implicit differentiation, section D, okay, implicit differentiation. Okay, compared to parametric differentiation and implicit differentiation, for further math students, you need to aware that these two parametric differentiation and implicit differentiation will be continued for further maths later. So please make sure you learn this properly. Okay, so implicit differentiation, better to show you by example. Okay, before you actually learn about what exactly is this, so let's try to look at some example first. Okay, so let's say I given, okay, given what x squared plus y squared equals to 4. Let's say I given this, so my objective is to find dy dx. Okay, let's say this is what I want to do right now. So I do explicit by x, this one explicit by y, this one implicit by x, this one implicit by y. Okay, so first, based on normal working, okay, I have x squared plus y squared equals to 4. Okay, under usual working, to get dy dx, I will usually write y as a subject first. So I have a y equals to plus minus root of 4 minus x squared. But the thing is, here I have two answers. One is a positive root, one is a negative root. So for simplicity, we just let it equals to 1 first. Let y equals to with the positive root. Okay, then after that, if we then we continue to find the dy dx. Okay, we do it like the usual what we did previously. So y here, then I have dy dx. So I bring down the power. Okay, power minus by 1 multiply by differentiate of the inside. So if I simplify it, a negative 2 cancel off. So I have a negative x over square root of 4 minus x squared. Okay, at the moment, this is what I get. So I just leave it at that first. So same questions. Maybe some students will say that, oh, I don't want to do it by ddx. I want to do it by ddy. Can or not? Yeah, of course, can. Okay, so if let's say I want to do dy, so I write x as my subject. So I have a plus minus root of 4 minus y squared. Okay, same thing. I have two roots here. For simplicity, we let it equals to one of them. Okay, only referring to the positive root. Let's see what do we get. So I do dy, I have dx over dy. Bring down the power minus by 1, multiply by differentiate of the inside. So if I simplify it, over here, this is a y to y. Okay, if I simplify it, I have a minus y over square root of 4 minus y squared. But this is dx over dy, isn't it? So we just flip them upside down. Dy over dx equals to negative of root 4 minus y squared over y. Of course, at the moment, the first column and the second column, the same dy dx, but it give you two different answers. Okay, we ignore them for now. Okay, we ignore them for now. So x squared plus y squared equals to 4 for the third column. Okay, same questions. Okay, but this time, okay, I'm not going to do any rearranging. I'm going to do it straight away by d dx for all the both sides. So I'm going to do d dx both sides. d dx here, I'm going to do d dx here. Okay. So what do I get? Yes, I have for 4, I have x squared plus y squared. According to differentiation rule, okay, basic rule, so I have a d dx of x squared plus d dx of y squared, and I have a 0 here. The first part is they are the same alphabet, x and x, so I can differentiate them just like usual. I have 2x. But for the second part, I have a different alphabet, x and y here. In order to tackle that, so I need to do a chain rule. Okay, I do d dy, then y square, then where is the dx goes? It goes to the back. Okay, it goes to the back. So now I have the same alphabet y and y, I can differentiate them. 2y dy dx equals to 0. Remember, our objective is to find dy dx, so I write dy dx as my subject. Okay, shift the 2x over, negative 2x, then bring the 2y over, so negative x over y. So this is what I get for the third column. Again, now you see that it's different from the first two. Okay, now we go for the last column. Let's say x squared plus y squared equals to 4. Okay, the third column, I do d dx. Maybe this time I do d dy. So d dy here, then d dy here. So I have a x squared plus y squared equals differentiate 4. Okay, according to differentiation rule, so I have a d dy of x squared plus d dy of y squared equals to 0. The first part, I have a different alphabet. Same thing, I'm using chain rule to manipulate the alphabet. Okay, d dx x squared. Where is the dy go? It goes to the back. Just like how we actually apply chain rule. So then after that, okay, I have a 2y here. This one goes to 0. Okay, now I have the same alphabet. I'm okay to differentiate now. I have 2x dx over dy plus 2y equals to 0. So I have a dx over dy equals to negative of y over x. But this is dx over dy, isn't it? So I flip them upside down. dy over dx equals to negative x over y. Okay, finally, the third and the fourth column, they are the same. Okay, well, what about the first two? Let's observe further. From the first column, I have a negative x over square root of 4 minus x squared. Remember earlier, we let y equals to positive root of 4 minus x squared. So this is actually a y. From the second column, we already let x equals to positive root of 4 minus y squared. This is actually your x. So all 4 columns, they actually give you the same answer. No difference at all. So if there is no difference at all, why do we need to learn implicit differentiation? Again, the reason we do implicit differentiation is actually tackle for non-function. Okay, the reason we do implicit differentiation is to actually tackle for non-function. Remember 4 types of relationship: one-to-one, one-to-many, many-to-one, many-to-many, the non-function. Okay, so what will be the advantage of doing implicit? Okay, number 1, we don't need to do any algebra rearrangement like here. Number 2, we don't need to exclude a certain case like negative root. We didn't exclude anything here. Okay, so this is the reason why we do implicit differentiation. Okay, so the example above demonstrates to you what exactly is implicit differentiation. Then, okay, implicit differentiation can go very difficult. Okay, so of course you have the simple one. You can have implicit with product rule. Okay, you can implicit with the quotient rule. Okay, you can implicit with the chain rule. Okay, so let's look at some example. So let's say my objective is to d dx of xy. This is example of product rule. So when we do our differentiation, just make sure you write it step by step. Okay, differentiate u, keep v, differentiate u, keep v, plus keep u, differentiate v. So your result will be y plus x dy dx. Okay, let's say I give you another one. Let's say you have a x squared ln y. Okay, differentiate u, keep v, plus keep u, differentiate v. Differentiate v, I better write step by step. Okay, differentiate v. Okay, so 2x ln y plus x squared, but over here you have a different alphabet, so we apply what we did earlier. So we have dy dx. So I have 2x ln y plus x squared over y dy dx. You'll get this as a result. So these two, they are the example of product rule. So what if we have a quotient rule? So x over y. Differentiate top, keep bottom, keep v, minus keep the top, differentiate the bottom over the bottom square. So you will get y minus x dy dx over y square as your answer. Okay, so what if I'll give you another quotient rule. Let's say I have sine x over cos y. Okay, sine x over cos y. This is not tangent because they are different things, x and y here. Differentiate the top, keep the bottom, minus keep the top, differentiate the bottom over the bottom square. So keep the top, I have a cos x cos y minus sine x. Over here, different alphabet, so I need to do changing of the alphabet here. Over cos square y. Then I have a cos x cos y minus sine x. This one become minus, so become plus sine y dy dx over cos square y. You will get this as answer. So this is another two example for quotient rule. Okay, now I go for the chain rule. Let's say I want to differentiate sine of xy. Okay, sine of xy. So there is an outside, there is an inside. Okay, maybe no, I don't go for this so difficult first. So let's say sine of ln y. Okay, sine of ln y. So according to chain rule, differentiate outside, keep the inside, multiply by differentiate of the inside. So I have a cos of ln y. This one is a different alphabet, so make them the same alphabet. Keep with the dy dx. Then I have a cos of ln y over y dy dx as your answer. So what if I have e of xy? Okay, e of xy. So differentiate, the outside is e, the inside is xy. Differentiate the outside, you still have e, inside you still have ey. Then multiply by differentiate of the inside. So you will see this now become a product rule. So you have a e of xy, then you have a y plus x dy dx. We can write this because we already done above. Yeah. Okay. So how complicated it is? It will be deal with the uh, the exercises. Okay. So we can look at the exercises. Okay. So these are some questions for the implicit differentiation. Okay. With this, we complete the differentiation topic. So okay, but the next lesson I will discuss something extra, which is called modeling. Okay, modeling. So this is on top of the differentiation topic. Okay, how do we actually write out the model of questions? Okay, so I let you practice this parametric differentiation and the implicit differentiation first. Okay, stop recording.